Hey guys, welcome back to another video, and today we're going to be solving the Leet code question reverse bits. So we're given a 32-bit unsigned integer, and our goal is to just reverse it and give that as the output. So let's say we're given this over here as the input, and we're going to reverse it. So what that means is when you read the input from right to left, it's the same as reading the output from left to right. So you have 0, 0, 1, 1, 1 over here, and that's going to be the beginning of our output. So 0, 0, 1, 1, 1, and so on and so forth. So yeah, let's just see how we can solve this in a simple manner. So let's say that we're given this unsigned integer as our input, and now what we need to do is we need to reverse it and find our output, which is the reverse version of our input. So what we're going to do is we're going to start off from here, and our output is going to start off with the value of 0. Now we need to have some way of checking if the bit has a value of 1. And to do that, we can use the AND operator. So this AND bitwise function, so we're going to do AND 1. Now what this does is we're only going to get a value of 1 when this bit over here has the value of 1. So if this is 0, if we're doing 0 and 1, we're going to get a value of 0. But if we're doing 1 and 1, we're going to get a value of 1. So we're going to be using that in order to find out whether the bit has a value of 0 or if it has a value of 1. Okay, so first what we're going to do is we're going to start off at 0 for the output, and we're going to start iterating through the beginning over here. So we're going to perform a left shift for our output. So what that means is we're going to add a 0 over here. And similarly, we're going to perform a right shift for our input. So that means we're going to add a 0 over here. But I'm not going to really show this because that doesn't actually matter for us. Now, what's going to happen is we're going to cross out the 0, and then we're going to go over here. And again, we're going to check if this has a value of 1. It doesn't. So we're going to cross that out. Now we're going to perform a left shift on our output again. So we add a 0. And now we're going to go here, and now we have to check, is 1 and 1 equal, is that true? So yes, 1 and 1 equals to 1. So what's going to happen then is we're going to change this value. Instead of 0, we're going to make it 1. Now we're going to do that again. So we're going to perform a left shift, so it's going to have a value of 0. But once we go over here, so we're going to perform a right shift here. We're going to go here and be like, oh, we have a 1 again. So we're going to add 1 once again. So we're going to just keep doing that. So over here we have a 1. So we're going to perform a left shift. We're going to have a value of 0. And then we're going to add 1 because we have 1 here. Now, again, we're going to perform a left shift. We're going to perform a right shift over here. And we have 0. So we're actually not going to do anything and let it be as it is. So we're going to perform this all for a total of 32 times, and what that means is we're going to keep going until we reach over here, and once we reach there, we're going to stop. So past this to the left over here, it's going to be filled with zeros because we performed a right shift each time, and that actually doesn't matter because once we reach the ending after 32 iterations, we're just going to stop the whole process. And so let's see how this looks in code. It should be a lot easier to understand. So what we're going to do is we're going to first set our output, and in the beginning we're going to just give it a value of 0, and we're going to put a for loop which goes through a total of 32 times. So for underscore in range 0, 32, and I just used an underscore because we're not actually referring to this. So yeah. So this basically means that we're going to be iterating through it a total of 32 times. And in the beginning, what we're going to do is we're going to perform a right shift on a left shift on our output. So output equals to output. Then this is how you represent a left shift and by 1. And a better way to represent this is you just remove all of this, and you can just put the left shift function over here. Oh, sorry, output. Right. And then afterwards, we need to check if our value in our input has a value of 1. So if n and 1 is equal to 1, or we could just leave it as it is, because if n and 1, then so if that does equal to 1, we're going to add the value of 1 to our output. So output plus equals 1. And after doing that, we're going to perform a right shift on our input n. So n, then right shift, and it equals 1. So you're performing the right shift on the input of n. And this is going to go for a total of 32 times. And after we're done with that, we're going to return our output. So let's go down and submit our code. And as you can see, our submission did get accepted. And finally, do let me know if you have a different or even a better solution to solve this. And don't forget to like and subscribe if you like this video. And yeah, thank you.